Well, good morning. I firmly believe that technology holds the key to accelerating evolution. That could be human performance, it could be acceleration of performance of man and machine, and it can also be extended, as I'd like to describe today, how you can actually improve performance and competitive advantage of organizations. So I'm going to talk first about sports, but then I'm going to extend into other organizations and other operations, far out to utilities and retail. I also believe that previous speakers have talked about the availability of cool new technology. I think what holds us back is not really the technology per se, it's the useful application of that technology, and then subsequently the adoption across industry. I also think the big data surrounds us. The challenge is, however, to extract value from the data, to actually unlock new levels of performance. So I also believe that as we get wider adoption of technology, we actually live in an instrumented world. I think we've reached a level of adoption of sensor networks and communication networks to allow us to consider the world in which we live in as instrumented. So physical events can easily be turned into software events. And with the previous speaker's technology working in the cloud, we can do anything we like with those data and actually produce something useful, something that we call actionable intelligence. But actionable intelligence is only the first step. If you actually accumulate the data and mine the data by looking at historical plus current data, we get to predictive intelligence. And at McLaren, this is really the starting point. But predictive intelligence isn't enough either. Where we'd like to try and get to is beyond predictive, get to prescriptive intelligence. Intelligence that actually allows us in real time to suggest winning moves. And when you can do that, you can truly change the game. But that also requires us to have a different approach to strategy. Because strategy typically is a static process. People will produce a plan to win. For centuries, people have agonized over what's the perfect plan that will give a successful outcome. Well, it's no different in sport as it is to business. We want to win, or we want to defend our position. But if we have a world that's constantly changing and a world that's constantly and pervasively instrumented, well, actually allows us to have a dynamic approach to strategy, a strategy that can take in real-time feeds of information to update our plan based on current situation, both for ourselves and our competitors, and refresh the plan. So actually, we plan into the future as far as we can foresee. The more we accumulate intelligence, we can mine the past to anticipate the future. So actually, we can start to plan as far ahead as we can foresee, and the further back we look, the further forward we can predict with accuracy. So you may consider this, that in essence, with a fully instrumented world, with correct intelligence, we can compete for a future in real time. Now that may sound far-fetched. You may think, well, surely that can't be done. Well, that's exactly how things are done at McLaren, and I'll show you how that applies elsewhere. In Formula One racing, a split-second decision or a split-second advantage can make the difference between winning or losing. And the challenge is we have vast amounts of data that we have to process. So we really do need to have a strategy that moves in real time. Because racing, like your world, is complex, fast-paced, highly sophisticated, and highly competitive. And it's also a very public sport. It's a sport that's watched by over 500 million people every fortnight, and performance is measured very publicly. And so it's crucial that we extract all the information that we can, feed that back into the system, and use it to drive a competitive advantage. So for us, data, objective measured data, drives everything that we do in the race. More than that, the data feeds into models that allow us to simulate how our car is performing in the moment and will perform in the future, and also how our competitors are performing relative to us. So we leave nothing to chance. On a single car, you'll take hundreds of streams of data, hundreds of streams of data generating actually over 1 billion data points in a race weekend. And those data are fed back to a distributed team around the world. So for example, this weekend there's a race in Korea. There will be 40 people at the track, but for those 2 people in the cars, there'll be 40 people in the garage, a management team up on the pit wall, and there will be an equal body of people back here in Woking, just half an hour away from here. And what's interesting is the strategy for the race will be driven from here in the UK. So data for us is everything because it drives the strategy in real time. Now you might say, how do we process so much data with such a large team and actually make sense of that? Well, that's precisely where the analytics comes in for us. We don't have time to think. If something occurs on the track, we can't ask the driver to do a couple of laps while we figure out what we're going to do next. We have to make a split-second decision. So what actually happens in the mission control is we have a team of strategists here who are observing what's going on in the race. At the start of the race, they would have had a plan. Like any strategy, they would have had a plan to win. But by the time they've reached the first corner, all hell can break loose, and so we have to reset the plan and rejig the strategy. So what's actually done is we run thousands of strategies in parallel based on the real-time information that's being fed to us. We anticipate scenarios. So we'll ask ourselves what-if questions. What if the car in front crashes? What if the weather changes in an unpredictable manner? Such that we can run a scenario so we actually know what action or what course of action to take when that eventuality occurs. Now, the advantage there is, 1, we don't have delay, but 2, we can actually rely on actionable intelligence real time during the race to give us prescriptive intelligence, so that when something does occur, we don't have any delay, we can immediately act and know what the best course of action is to yield the best possible outcome. So again, for us, we have a completely dynamic approach to strategy there. Now, one of the most unpredictable elements of racing is the weather. A sudden downpour of rain can actually change everything because the system or the car has been set up to be driven in a certain set of conditions. But a sudden downpour means the grip is lost, the handling is changed. Then a very straightforward decision really needs to be made. But it's a very difficult decision to make under stress. So think of this, you've got to take a decision. Should you bring the car in and bring it to a stop to change tyres? Albeit you can change the tyres in maybe 3 seconds, you may lose 20 seconds just driving down the pit lane. But that's why while other teams are racing at up to 200 miles an hour. Now that 20 seconds might not sound much to you, but last weekend the difference between the first car and the fourth car was less than 10 seconds after almost 2 hours of racing. So it does show you actually how tiny losses of time are crucial. And so the tiny loss of time of scratching your head wondering, is it worth taking a tyre change? Can I afford the gap of time without losing my position on the track? It's too much for us to allow the operators to have to think about. So again, we rely on prescriptive intelligence to actually communicate, if such a thing happens, this is the course of action. So we actually are anticipating the future and looking out ahead. Now, we're not saying that we can predict the future. If we could, we'd win every race, and we don't. But what we can say is we can adapt on the fly to situations as they change around us and look forward and continuously plan based on current situations looking into the future. Now, just as we wouldn't race a car using a dashboard that was telling us how well we were performing 5 minutes ago, why would we run a business with a strategy that's based on sales performance last quarter or last month? So many companies actually do run that way. They'll have a strategy that gets produced ritualistically in January, and then that's followed throughout the year using a famous balanced scorecard, and then it's rewritten at the end of the year. But how many businesses actually take real-time data, real-time analytics, and try and anticipate the future? Actually measure present data use that to provide actionable intelligence on the performance of their business and moreover their competitors, and use that to have a dynamic approach to strategy to revise their plans as far into the future as they can see. Well, it might surprise you that one of the first areas where we took this approach was in other sports. So we're currently actually working with 5 British Olympic squads with just this intent. We're actually trying to enhance performance. I'll maybe just use this one example to illustrate the point. If you take an athlete or a sports person, they always want to get the best out of the body. But if they actually want to measure the physiological vital signs, it's actually quite complex for them to take the measurements of heart rate, position, maybe impact, then process that data to produce actionable intelligence. So what we've done is produced essentially a body area network using apparel that you can wear. So actually the sensors are imperceptible largely to the athlete. And then we can get a profile of their vital signs. Now, what we want to know really in most elite sports is how do I train for an event? So if I push an athlete hard, I can actually cause damage. I can overtrain them such that they're at greater risk of injury in the actual competition. So actually, you see, they want actionable intelligence during training to actually see, are they getting this athlete to a level of performance without running the risk of injury in the game? Then the question that people really want to ask is, how do I know to train an athlete, and how can I predict what the performance will be in competition? There are gaps there, and most of them are in the gaps of our knowledge of the physics and sports science. But by capturing the data, most top sports teams now are gathering vast amounts of data and trying to do just this profiling and predictive estimates of performance. Now, the vision that we have for team sports is just like in racing, what if we could do in-game strategy? What holds us back is not the technology, it's the regulations that don't allow us to use this technology in sport. But if we can use it in the battlefield, why couldn't we use it on the pitch? And actually, there is the capability here to actually manage a team of individuals for high performance and real-time execution based on events as they unfold on the pitch. Let's take a different challenge, air traffic control. Air traffic controllers have a really tough job. They're just like the engineers in a race. They have to process vast amounts of data, and it will surprise you that they make their decisions manually. They get feeds of information, yes, they get quite simple presentations of information, but they have to make judgment calls, which is why they can only work for short bursts without having rest. What if we could instrument an airport, monitor the planes as they're landing, and actually help the operators take what sounds like a simple decision, but it's difficult to take under stress. When a plane lands, what's the best gate to send the plane so that you minimize the taxi running time? When a plane's taxiing, it's dumping vast amounts of CO2 into the environment. Worse, when a plane arrives at an airport and you're flying around in circles over London, dumping vast amounts of CO2 over Oslo. That can be avoided. And it's actually rather simple. If you treat the local area as a network, measure the plane and the taxis as nodes, you can actually provide the answer to what sounds like a simple question. What's the optimal route to the gate? What's the time required to get the ground crew to the gate once the plane lands? I mean, how often have you arrived at an airport and that hasn't all worked so seamlessly? That's because this system has yet to be deployed. It's actually being used now to mine historical data to predict accurately up to 2 hours into the future what the optimum route should be. So you can actually do real-time analytics to increase the through flow through an airport, minimizing also the environmental impact. If you could maximize the through flow through an airport, you defer the capex requirement for an additional runway. That keeps the environmentalists happy, and it also keeps the airport operators efficient. Another example, maybe a more grounded example, traffic management. If we, as we do, have sensors in cars, and we can even, in modern cars, have control units in cars, just like you do in an F1 car, you can use the car as an emitting sensor. The car's driving through an environment that already has a pervasive communications network, so we can choose whatever bearer we want to transmit the information, but we can get phenomenal intelligence about how to optimize the flow of traffic. But again, this isn't actually implemented today. This is under development. If we monitor the movement of cars, can we synchronize the lights such that the flow is maintained optimally? Can we open a hard shoulder on a motorway to increase the flow based on real-time data of traffic? But it would be far better if we could actually anticipate the traffic peaks. Instead of what we do today, we use operators who manually look at screens and make reactive judgment calls. Actually, we have the technology to monitor the movement in real time and make predictive judgment calls. They don't need to be 2 hours into the future, but at least it ensures easier operation for them and better flow of traffic in our cities. Another different angle on the same challenge, if you've instrumented the car for traffic management, you can also use that same instrumentation to actually help the driver drive better. So I thought the comment this morning about drive to work and how all of that was wrong, I smiled because there is the potential that, yes, we could drive you to work if we have a controller in the car. Also, if we analyze how you're driving and where you are in real time, it's absolutely possible to give you an early warning signal, a predictive intelligence output that you're going far too fast for that dangerous corner that is literally just around the corner. That technology is there. That technology has been scrutinized in detail from road safety point of view, but also from the insurance point of view. They'd love to know how you really drive, and they can monitor your performance in the car real time, accumulate your history, and give you a premium discount. Well, that's how they would say it for sure. So, in another area, I mentioned how in racing, weather was one of the most unpredictable elements. Well, actually in retail, weather has a massive influence on the way people would want to stock the shelves. It's no surprise when you get that freak sunny day in November that you walk into your local supermarket and it's full of rosé wine and salad, totally out of season. That's because by real-time analytics, we can actually anticipate the weather in the future and stock our shelves accordingly. But what we'd like to be able to do is adapt on the fly, because the weather forecast is never normally accurate. You'd want to adapt on the fly what the stock should be as the weekend unfolds, day to day. You want to compress the time from when you have to decide when to stock based on the actual information you're getting fed. So the optimum point is to try and plan as far into the future as you can foresee accurately. And there are retailers now working in just this fashion, dynamically adjusting their strategy based on vast amounts of real-time data. What we're trying to work with them on is to optimize the supply chain. If you can actually instrument the products that you're producing, distributing, selling, and then ultimately consuming, if only you could tell where those products are and the context of their consumption, you can optimize the supply chain. So for once, you can actually match supply and demand in real time, and you can also gain a competitive advantage because you minimize the stock that you're accumulating. You can also dynamically adjust pricing on the fly in response to your competitor moves. So those examples may sound far-reaching, but actually they're not just visions, they're reality. They're reality of where people have been early adopters of real-time analytics using vast amounts of data to give themselves a dynamic approach to strategy and a competitive advantage. They are real examples of where people are, in essence, competing for the future in real time. Thank you.